Okay, let's start. Okay, so turn on video. And today, okay, so at first I want to announce several things. Owner option assignment supposed to be written recap of. If you registered for the owner's credits for this course, then you have to write a short report based on your final project. So that means it's statistical, the short report. So starting with introduction and followed by the methodologies and data description and your analytical results and conclusion. So just standard format. And I forgot to make the Sonali's the presentation comments available last week. So comment on her presentation by at noon on Saturday. And today's presentation, we have the 5 in-class presentation. Hopefully, I haven't seen the Jose's presentation sheet. So Jose, can you upload your presentation file as soon as possible? I will make your presentation at last. And we have some video presentations. So we are likely to have the 2 video presentations for today. And the Claudia's presentation is, Claudia's presentation is already available and Nadia's presentation will be available. Okay, so that's it. And after the presentations, I will also post the form to vote for the best 3 presentations out of all presentations. So that form isn't available yet. And all comments are due Saturday at noon. Because I have to grade it and I have to submit the grade as soon as possible. So sorry that you don't really have much time to comment on it. Okay, so that's it. And yeah, so now that we start the presentation, so maybe Neal, are you available?
Yes.
Yeah, can you share the screen?
Yes. Okay.
Okay, it's good. So you can start at any time.
Okay, so I'm just moving the bar out of the way real quick so I can see. Okay. So I did mine on the analysis of the stock market using several factors. The data. I used the Federal Reserve's total assets, the M2 money supply, the federal funds rate, the US dollar index, and it's being compared with the S&P 500 index. These were chosen just by, I did a cursory review, just looking into what things affect the stock market in general, and chose these after looking into it. The S&P 500 is a market cap weighted index of 500 of the largest US companies. And it's considered by many professionals to be a proxy for the health of the US stock market as a whole, and also for the whole economy. And movements in this index can reflect the investor sentiment and economic outlook. The M2 money supply is the measure of money that is readily available to be invested. It includes cash, checking accounts, and easily convertible near money. And its purpose is that it shows liquidity in the economy. An increase in the M2 money supply shows loose monetary policy, which can lead to more capital available for investment into stocks. The Federal Reserve's total assets is another variable, and it's the sum of all the assets held by the Federal Reserve, and it can include securities and also mortgage-backed securities. It shows the level of monetary intervention, and rapid growth in its balance sheet can signal potential inflation, which can also impact the stock market in various ways. And there's the US dollar index. and it measures the value of the US dollar compared to other currencies around the world. It's most of the important ones, like including like the euro and the yuan and other currencies. And its importance is that a strong dollar can reduce the value of foreign investments and also discourage investors from getting into the stock market because they are getting a good return with their US dollars. And then there's lastly the federal funds rate. And this is the interest rate at which institutions lend each other funds overnight. And a lower rate can encourage borrowing and investing, and that includes the stock market. And a higher rate can cool interest in the stock market. All this data is available at the website called FRED, which is basically the data repository for the Federal Reserve. Other than the S&P 500, which is available at almost all financial websites. Some of these sets of data include monthly data, some include daily. So I made all the series monthly. And for consistency, the last day of the month is used when selecting the data points. And because of the historical record of these, I chose to start with values starting in December of 2002 in order to avoid having gaps in any of the variables. The first thing I did was to plot from my data each variable versus time. And some similarities is with the S&P 500 index, is the Federal Reserve's total assets and the M2 money supply share some similar shapes, especially with the final peak and the slow gradual increase. The federal funds rate seems to be, and also the US dollar index seem to be affected by other factors, but we'll see how they contribute later on. The first linear models were made for each variable individually, along with one for the square root and log of each. And the purpose of this was to be able to compare their QQ plots to select the best model to go with for each variable. And on the next slide, when I was making the plots for these, the titles had an issue with formatting, so they're like the letters would overlap, and I couldn't resolve this. So it starts with the M2 money supply first, and then the square root of it, and then its log, and then it repeats in that order for DXY, which is the dollar index, WALCL, which is the Federal Reserve assets, and then Fed funds, which is the federal funds rate. So for the M2 money supply, it's a relatively straight QQ plot. There's some divergences. And also for the dollar index, it's also very straight. For the WALCL, it was hard to select. It was hard to select a good one, so I ended up going with the log plot, which is the third one. And then for the federal funds rate, I went with the square root. It seems to be slightly more along it, but they're not. I'm not very satisfied with their results, but those were the ones that were chosen. Yeah, the chosen ones were the M2 money supply, the dollar index, the Federal Reserve assets, and the log of the Federal Reserve assets, and the square root of the federal funds rate. Those are the ones that we're going to be using to proceed with the analysis. And next, we'll look at the linear model for each of these individually. So for the M2 money supply, it has a very low p-value of 2 times 10 to the negative 16. And its adjusted R squared is really high at 0.94. So a lot of the S&P 500 is explained just from the M2 money supply. And for the dollar index, it also has an extremely low p-value, but the R squared is lower at 0.45, about 0.45. And then for the federal funds rate, it's not significant based on its p-value of 0.53, and its R squared is almost 0. And for the log of the Federal Reserve assets, it has a very low p-value of 2 times 10 to the negative 16, and the adjusted R squared is about 0.64 to 0.65. So using these choices, a multiple linear regression was made, and here you can see the coefficients as well as the intercept. And what I thought was interesting is that the dollar index has a p-value here that is extremely high, 0.91. When it's by itself, it was pretty low. And also for the Federal Reserve assets, sorry, the federal funds rate, it has a very low p-value here, but on its own, it was very high and insignificant. Next, it was optimized by minimizing AIC, and this resulted in dropping the dollar index from the model, which was expected because it had such a high p-value. As you can see, it dropped the AIC by about 2 points, and the final model that was called the best model has these intercepts and coefficients. And the adjusted R squared for this is 0.97, which means that over 97% of variation in the S&P 500 can be explained just from these three variables: the M2 money supply, the log of the federal funds assets, and the square root of the federal funds rate. Next, to plot the residuals. They look pretty evenly distributed above and below y equals 0. But there seems to be greater divergence as the value increases. And also plotting it with time, it looks to be pretty similar, which as time goes on, the variation increases, but it's still evenly spread in general between positive and negative values. And next, I wanted to take a look between the correlation between the different indicators. So with the S&P 500, it was mainly the M2 money supply and the Federal Reserve assets that were very closely correlated to it. And all of the other indicators were not only not that correlated with the S&P 500, but also with each other. They were very uncorrelated, other than the Federal Reserve assets and the M2 money supply being also closely related with a 0.93. Or I'm sorry, a 0.98. Some notes about what was found is that we discussed independent and identically distributed data and IID errors in our class. And in a time series, often the consecutive observations are highly correlated. Because of this reason, I attempted to use the first difference of time series, which is the log of x of xt minus the log of x of t minus 1. But the results that I was obtaining from that were p-values that were almost all over 0.4. So I decided to switch to the method that I was familiar with from class and plotted the residuals against time in order to check this, and it seemed like it was evenly distributed, so it was valid. Some possibilities to do with this, to improve it, would be to use more variables in the analysis process that could later be determined to be dropped by AIC. Also, to gain a better understanding of how to deal with the time dependence issues, since I was largely unfamiliar with that. And also to see how this model holds up when the future data comes in the coming days or weeks or months. For the conclusion, the best effort was made in selecting the best transformation per variable, whether it was a square root or log, or just keeping it as it is, based on the QQ plot. And the model has an R squared of over 0.97, which is extremely high, and it has relatively even residuals overall. The AIC has been reduced slightly, and the individual variables have been analyzed. And the correlation between the indicators has also been looked at and analyzed as well. And that is all.
Hey, thank you, Neal. I have some clarifying questions first. So what the WALCL stand for?
That was the Federal Reserve assets.
Federal Reserve Asset. Okay.
I don't know why it was labeled as that. That's just
Yeah,
what
I
it
don't
was
know.
on the website,
Okay,
so I
I see.
kept it.
Okay. And for regression models, what transformation did you use? You used the original scale or the first difference for each of the series?
I used the original scale, but I used the log and square root for
Okay, original scale, but okay,
yes.
I see. I
I
see.
use the log for the Federal Reserve assets and square root for the federal funds.
I see. So I think that your note is important. So that we have a lot of time dependence you can see from the residual plots. So
Yes.
yeah, so I think the
Okay.
most of the series you have to take the first difference. Yeah, so at least maybe M2, SP500 and total assets, and the rate and the dollar index, maybe it depends, but yeah, so we have to avoid the all dependence to make the p-value the unbiased.
Okay.
But yeah, yeah, it's interesting analysis. Yeah, I worked for the central bank for 5 years, so
Oh,
yep.
okay.
Does anyone have questions to Neal?
I have a question.
Okay.
When you said like in your note that you did like the difference between like the log of the difference and
Yeah.
for the time series one, so were you able to do that, or did you do it in this analysis, or were you able to see the residual plots?
Yes, I did it, but I ended up not using it because the p-values were so high when it was almost
Oh, okay,
uncorrelated.
got it. Okay, thank you.
The residual plots looked good, but
Yeah, I think probably
that was
that's
it.
the true relationship. Yes. Actually, the p-value isn't that high. Yep. Okay, any other questions?
Okay.
Yeah, thank you, Neal.
Okay, thank you.
Okay, so next, we have presentation. Ada, not here.
Yeah.
Oh, yeah. Can you share the screen?
Yeah. Let's see. Okay. Can you see that?
Yes.
Okay. So for my analysis, I wanted to look at regional differences in Medicare spending. So when developing any policy, I guess the ideal of it is that it should affect everyone, everywhere in kind of the same way. And so for a federal policy such as health insurance or Medicare, if there's any variation, say geographically, that's an important issue to look at. And so that's what I was trying to examine in my analysis, is any geographic variation in Medicare spending. So I chose a data set that included per capita standardized spending on 21 chronic conditions from each US county in the year 2018, which was the most recent year for this analysis. And so here are the chronic conditions. And for my analysis, I just totaled these up. And so the data I'm looking at for the spending, probably for this presentation, I'll just refer to it as Medicare spending or per capita Medicare spending, but it's really the sum total of Medicare spending of these 21 chronic conditions organized by county. And so here's a overview of the data, and it's I organized it by the 9 US regions. In case you're curious, Michigan, we're in the East North Central region. And all of those points on that plot are just the different spending that I calculated for each county. And so I wanted to test the null hypothesis that the group means among these are equal. And so to see if a parametric test was appropriate, I first wanted to assess normality. And I found that there was a negative skew in the data, and transforming the response variable did not establish normality either. And also the variance was not equal. As you can see in that box plot, there is a lot of outliers in the data. So I decided to go for a Kruskal-Wallis test, which indicated that there was significant difference in per capita Medicare spending on chronic conditions among the 9 US regions. And so from here, I wanted to look at what was driving this regional variance. So I went looking around for other data sets, and I found one called Medicare monthly enrollment data. And this is a data set that includes for every county a total count of Medicare beneficiaries, as well as subpopulations that tally up beneficiaries by the type of coverage they receive, and also whether they receive coverage due to age, being 65 or older, having a disability, or having end-stage renal disease, also known as kidney failure. And so those are like the three main ways that people get on Medicare. And so what I did with this data is I removed any multicollinearities between to get like the most salient data points or the most salient variables from this data set, because a lot of the tallies are like subpopulations of others. And I also organized the data by state because it was organized by county before. And I also calculated the statistics of the subpopulations of Medicare enrollees relative to the total amount of enrollees for the county, because I thought that a proportional measure was a more meaningful measurement compared to per capita spending. And so I found these 4 predictor variables to build my first multiple linear regression off of. And it's the proportion of beneficiaries under original Medicare, those under Part A and Part B, those that are 65 and older, and those that are not 65 and older that have end-stage renal disease. And so I put these into a model to see how well they would predict per capita spending by state. And what I found was that the only significant predictor was the proportion of beneficiaries with end-stage renal disease, which was interesting to me. And so you can see that the residual plot as well as the QQ plot of the residuals shows that it's not as randomly distributed, the residuals, as I'd like to see. And so I wanted to see if I could find other data to find other predictors for this per capita spending to see if I can make this model more robust. So I went back, looked for more data, and I found this data set that included data from hospitals that were treating Medicare patients as well as receiving funding from Medicare. And I looked through the data, I removed any multicollinearities, and I was able to add 2 new variables to my earlier model of Medicare enrollees. And this was the number of discharges, so the number of Medicare patients that were discharged from hospitals within a state in that year of 2018, as well as the average Medicare payments that the hospitals in the state received from Medicare for that year. And so I added these 2 variables to my model, and then I made sure that there wasn't any collinearity between the independent variables. And then I found that for this regression model, there was a significantly better fit than the model that only included the Medicare enrollment subpopulations. And you can see that the residual plot is much more evenly distributed, and overall, it just seemed better. But then also I wanted to look at Cook's distance to see if there's any variables with an outsized influence. And so that was something that I was interested in. And I did some extra analysis on that I'll take a look at. But before that, I did backwards selection on this model to see what the most significant variables were that contributed to Medicare spending. And so I removed 1 variable at a time until all the variables were significant with a p-value under 0.05. And I found that the significant variables contributing to spending were the total number of Medicare patient discharges from hospitals within the state, as well as the proportion of beneficiaries with end-stage renal disease. And those both had a direct correlation, and then there was an inverse correlation with the proportion of beneficiaries 65 and up. But then at this point, I wanted to look at, so for Cook's distance, observation number 11, which is Hawaii, looked like it had an outsized influence on this model. So I removed it from my data set, and then I did the backward selection again. And I found that after that, the correlation or the significance of the proportion of aged beneficiaries disappeared. And so that left us with the significant variables on influencing Medicare spending by state being the total number of discharges from hospitals, as well as the proportion of beneficiaries with kidney failure. And so I think that intuitively this data makes sense because it seems that higher rates of inpatient care or hospitalization correlating with higher per capita spending makes sense because inpatient care does seem to, or inpatient care does tend to be more expensive than outpatient care. And then having a higher proportion within a state of beneficiaries with kidney failure might increase the per capita spending costs because kidney failure as a chronic condition might be more expensive to treat than other chronic conditions such as asthma or hypertension. But yeah, overall, there was significant regional variation in Medicare spending and on chronic conditions. And I hope that I provided evidence of that could explain some of this variation. Of course, there's a lot of other possible contributing factors, and that includes demographic variables or access to healthcare services being some other things that might be interesting to look into. So yeah, thank you.
Oh, okay, thank you. So does this mean that the cost difference per capita that depends on these medical conditions? I mean, explained by medical conditions with like 56% or something. So I thought that a larger factor is like the price level between regions, but actually medical conditions explain the majority of the reasons.
So I think that by price level, I hope I'm understanding you correctly, but I think that, so there's the data that I was looking at on the spending was standardized so that differences, and I think like hospital, like price levels and like the average cost of receiving care.
It's already standardized by the price level.
Yeah.
Okay, I see, okay. Okay. Does anyone have questions to Ada?
Why is it that Hawaii and observation number 18 and 28 had such large Cook's distances? Was there anything special in the data that might have indicated something, like for some reason for that?
Yeah, so I believe that Hawaii was one that had a large Cook's distance, and I think the other ones were Nevada and Louisiana. And my assumption, at least for Hawaii that I was looking at, was maybe a lack of data. And also there is probably, because I think there's fewer counties in Hawaii as well as fewer counties in Nevada, I believe, that might have had an influence on like how much weight the observations had or from the data collected, as well as looking at inpatient data. Some areas have much higher access to hospitals than others, and I think that could also have contributed to that variation.
Also, I want to know, did you use off-white for the background? It looked nice.
I don't know, but thank you.
Yeah, Hawaii is different in many ways, you know, the temperature is different, but the racial decomposition is different. Price structure is different. So, you know, food is expensive, but the labor cost is cheap. So I don't know what factor affects, but yeah, certainly it's different. Okay, so does anyone have more questions? Okay, thank you, Ada. And next, maybe the Breeanna. Sorry, maybe Breeanna. I misspelled it, but yeah.
Yeah.
Can you share the screen?
Yes. Can you see my screen?
Yes.
Okay.
You can make a full screen mode or something. Yeah. I can see the slide, but I can see some redundant information. Oh, but US showing in browser. Oh yeah, it looks better. Yep.
Okay. So I did mine on the impact of athlete measurements in gymnastics. So just a little history of gymnastics in general. Artistic gymnastics is the challenging of one's abilities to perfect their skills on various equipment, such as the parallel bars, balance beam, floor, and vault. And an ancient Greek theory that I saw that was interesting was symmetry between the mind and body was possible only when physical exercise was coupled with intellectual activity. And that was from the Olympics website. And I included some interesting facts about gymnastics was that 32 years ago, only men were allowed to compete in the Olympics. So my presentation is all about the women in the Olympics. And the balance beam for women is only 10 centimeters, which is 4 inches. And that is very tiny. And being that it is easier to train your body for flexibility and strength at a younger age, gymnasts often reach their peak performance at a young age. So the factors that I'm considering in my presentation are their age, their weight, and their height. And I included a picture of Simone Biles next to Shaq, and there is a big difference of their sizes. So again, I am testing the variables height, weight, and age, and how they impact the success of gymnasts in the Olympics. My data set, I found my data set on data.world, and it was a whole data set of all the Olympics from, I think it was like from 1990s all the way up to 2016. And in total, there was 271,116 entries, which was a lot. And like I was saying earlier, I wanted my presentation to be on just the women. So when I was pre-processing my data, I had to remove all the males. And then I also had to remove all the other sports that were there. So as you can see, there are 15 columns. Each one was the name, the sex, the age of the athletes, their height in centimeters, their weight in kilograms, the team that they played on, the nation that they played on for, what year they played for, the season, the city, the sport, and the event that they were competing in. And also in the last column is the medal. So as we can see, there are NAs and there's a gold. And NAs mean that they did not win a medal in their competition. And then there was 3 other categories, which is gold, bronze, and silver, which means that's what they placed. So pre-processing my data, first I removed all the male data, and then I removed all the sports that are not gymnastics. And then as we can see in the name column, there are multiple names of the same person. So I had to remove their names just to eliminate duplicate data. And then also in the medal column, there are NAs, and I converted those NAs to 0, which means they did not win a medal. And then gold, bronze, and silver, which equaled 1 is what I put, which means they did win a medal. And then the total entries after all the pre-processing was 1,499 entries. So I first plotted the age, the height, and the weight of the data that I found. And then the mean age was 18.58, which was pretty young. And then the mean height is 155.77. And then the mean weight was 47.26. And there are different levels of the height and ages, as we can see in the box plots. And then I also did a correlation test just to see how these variables correlate with the medals that they won. So I chose the letter Y to input my data in, and that is when 0 equals Na and 1 equals the medal that they won. So when I compared these variables to the Y variable, I found that the age was correlated. It was close to 0. And then the t-test was 5.3. And also the p-value was less than 0.05. And also for the height, the correlation is close to -1. And the t-test is very small. And then the weight, the p-value is also less than 0.05. So then I did a t-test to compare these differences. And again, I converted these data into a box plot for Y against the height, Y against the age, and Y against the weight. And then these t-tests on the bottom, I included that the p-values for the height was less than 0.05. The p-value for the age was also less than 0.05. And the p-value for the weight is less than 0.05. I next did a linear regression, and comparing the residuals and also the coefficients, and also again the p-values, we can see again that they are significantly different. And the top left one was for the weight, the top right one was for the height, and the bottom one is for the age. And then in summary, the variables are significant enough to determine if a gymnast is awarded a medal based on the models that I tested. However, some missing measurements were missing from the data set, which may play a role in my test. And as we can see back in here, under the residual standard error, we can see that 369 observations were deleted because that means that their weight was not included in the data set. So that could have a possible factor determining the analysis. And then some future research ideas that I thought of what could be interesting was testing the significance between the genders, because being that females are usually smaller than men, I would like to see how that would differ if I compare the different genders. And then also comparing the sports, being that gymnasts usually have a smaller stature compared to swimmers, I would like to see how that would differ. And then also comparing the feet size versus the success on the balance beam for gymnasts. Like I was saying in the beginning of my presentation, the balance beam for a women's sport is 4 inches. And I would like to see how their feet size compares to their success on the balance beam. And that is the end of my presentation.
Thank you, Breeanna. So if my understanding is correct, so basically the shorter person and lighter person performs better, and the higher age performs better in this population. Is that right?
Yes.
Yeah. So okay, I see. So smaller has more advantage, but still the more experienced person,
Correct,
performs well. Okay, I see. And how did you remove the multiple measurements of individuals? So you said, yeah, suddenly we have many multiple measurements because
yes.
the one, yeah, so how you remove that? I mean, which one you removed out of several lines?
I used the code, the duplicated code in R, and that allowed me to remove the different sports and everything, or the different names, I'm sorry. Because the names are duplicated, so it uses the duplicated code to remove the names, so that only one name.
Yeah, for example, the line 6 to 11 are the same person, so you have to remove maybe 5 of them and keep one of them. which one did you keep?
I kept, well, this one I didn't actually do because this one is not gymnastics.
Oh, okay. So, but anyway, but okay. So, but anyway, you
Yeah.
didn't really analyze at sport level, so it maybe does not really matter, maybe much. I see. Okay, great. Does anyone have questions to Breeanna?
I have a question.
Yeah.
Your idea that you had at the end of like analyzing shoe size against the performance, do you know if that's like data that they keep track of?
I am not actually sure. I want to find out because I'm actually really curious on how the balance beam and their feet work compare. So that is something I would like to see in the future.
Does anyone have other questions? Yeah, I think in the past, in a little more advanced class, the one student used the athletes data for all sports and identifies the given your the body dimensions, which sport is the best. So that may be interesting idea as well. Okay, thank you. It's interesting talk. And I found that the Jose will not make a presentation today, and for the last one is Sakina. Hi.
Hello.
Can you share the screen?
Mhm. Can you see the screen?
Yes.
Okay. Hello, I'm Sakina. So for this project, I was looking at the if race had an effect on the prevalence of anxiety and depression symptoms or prevalence of anxiety and depression in children in the US ages 5 to 17. So here's an overview of what I'll go over. So first to go over the my objective slide was supposed to be next. So my objective of this project was to see if there's racial differences. If the race had an impact on the prevalence of anxiety and depression in the United States for children under the age of 18. So where my data came from, so I collected data from the National Health Interview Survey, which is run by the CDC, or is run by the it's run by a group under the CDC who, sorry. The survey data that I took from was from 2022. This survey The survey collects national data from a broad range of health topics, and one of the topics that it also includes is mental health, in particularly anxiety and depression. For my sample, this survey has an adult sample and a child sample, so I took my data from the child sample. The variables that I used were these three. So for the first one for race, the second for anxiety frequency and depression frequency. And the total number of observations in this data set was 7,464. So looking at our variables, the first one I have here is the questionnaire for race, and the options that were that you would select from. So there is white, the first one being white, second one Black or African American only, Asian only, AIAN, which is American Indian, Alaskan Native, so indigenous peoples. Then in AIN or another racial group, and then other, so any other single or multi-race. And then because it's a survey, there are options to refuse the question, or like if the data is not ascertained or don't know. And then from these descriptors, the data was recoded numerically. Next is the variable of anxiety. So the question that was asked was, how often does seem anxious, nervous, or worried? So the questionnaire was most likely given to the parents or guardians, caregivers of the child, and they're asked about their child. So the anxiety and depression were like Likert scale questions. So the options that they would choose from would be daily, weekly, monthly, a few times a year, never, and then refuse, not ascertained, or don't know. And then those were recoded. So as you can see here, there was about 2,000 observations that were missing. And next, for depression, for the depression frequency, for the depression variable, the question that was asked was, how often seems sad or depressed? And it's the same Likert scale, same type of coding. And as you can see, there's still 2,000 observations that were missing. So from that, we can see that the for anxiety and depression, both those questions, like all of the missing, were missing for both questions. So okay, here it explains what AIN and other mean in this this bar graph. So I took a bar graph of the race to look at the descriptives of race. And as you can see, white is obviously the highest here, and it's substantially more frequent than the other races here, which can reflect the demographics of across the US. And then second, the highest being Black, African American, Asian, and then other. So this bar graph was taken before removing the missing values. And the bottom here is the proportions, which compared to after the missing values are removed, the proportions seem relatively equal. Obviously, there's a decrease in every single option, but it doesn't, like, proportionally doesn't change that much. So can move on to the rest of the analysis. So here was the bar graph for anxiety frequency, and never was the highest here. But I thought what was surprising is that a weekly symptom showing weekly was still higher than the monthly. But yeah, there is a increase there. Here shows the proportion of those that selected that they had any type of like symptom throughout the year versus not. So 0 was never, or refuser didn't know. And then 1 was coded as daily, weekly, monthly, or a few times a year. So I was surprised that there was higher than the never was any symptom at all, especially compared to depression, where we see here that never or refuse or don't know was higher than any symptom throughout the year. So I thought that was an interesting factor, that there's more, that we see more likelihood of depression, of anxiety symptoms rather than depression symptoms in children under 18. So I wanted to test here was if there is a difference between the prevalence of anxiety depression by race. So I ran a chi-square test of independence to see this. So here was the contingency table of anxiety by race that I used to do the chi-squared test. So it looks here that white would has the highest here, and it's hard to tell if there is any difference by race. That's what we use the chi-squared for. So my null hypothesis is that there's no relation, and the alternate hypothesis is that there is some relation between race and anxiety frequency. And doing our chi-squared test, our chi-squared value was around 200, so 174.58 or 58. The p value here was quite small. It's much smaller than 0.5. So we can conclude that our findings were significant and that we can reject the null hypothesis and conclude that there is some relationship between the race and, or that there is a difference of anxiety frequency by race. Next here's the contingency table of depression frequency by race. And here's the chi-squared test. So again, same null hypothesis and alternative hypothesis looking if there is any relationship. Our chi-squared value came to a lot smaller of 77.27, and our p-value is still significant, but not as significant as the chi-squared for anxiety by race. And we were still able to reject the null hypothesis. And so there is still some difference by race in depression frequency. Next, I ran a logistical regression to see how much does race predict the prevalence of anxiety and depression. So in our logistical regression for anxiety by race, our predicted variable was race and our outcome variable was anxiety, which was recoded as a binary outcome. So daily, weekly, monthly, and few times a year were coded as 1. So it's like any prevalence, and then never and don't know were 0. And here we see that for white, Black, African American, or Asian, there was a significant significant finding, and also surprisingly for not ascertained, it was also significant, which I thought was kind of interesting. It must be because they're just a lot higher number of participants that didn't ascertain their race, but still had some symptom of anxiety, or put some symptom of anxiety or prevalence. So here we see that for white, there was about 3.4% of the variability in anxiety prevalence can be related to by race. So that's the same for Black, it's slightly higher, it's 8.7%, and for Asian only it was 10.5%. And then we took the linear regression, or not linear, the logistical regression for depression by race. And here our predicted variable was race and our outcome was depression, also in a binary outcome, the same sort of thing we did for anxiety. And the results were pretty similar. Same again for white, Black, African American, and Asian. Only were all significant, and again, same with not ascertained was also significant, but they were significant at different levels. So white was a lot more significant than Black, and Asian American was only significant at a 0.5 per p-value.
Yeah,
So
12
5%
minutes, so wrap up.
Okay. And here we have the percentage of how much race is a variable of anxiety. So in summary, there was a difference of anxiety and depression prevalence. By race, there was a significant difference. And there was also, race was also a significant predictor of anxiety only for white, Black, African American, and Asian children. So some limitations of my project and my analysis was that surveys are self-report data, so not everyone will give a like specific thing that you're looking for, answer that you're looking for. They might not even answer the question because that's in their like free range to do so. And also our data was a really wide age range from 5 to 17. So the prevalence could be different in each age, depending on age. And another limitation was that this survey only had one question for anxiety and one question for depression, as like, and that was the only question I could use, but they lacked other ways of testing for anxiety and depression symptoms, or like somatic symptoms for depression, to give a like better view of the symptoms and the prevalence. And I also lacked predictor variables in my logistical regression. So it'd be interesting to look at age or other demographic variables if that also has an effect on the prevalence of anxiety and depression of children. And that's it.
Okay, thank you, Sakina. Yeah, I think it's the good comparison of chi-square test and the logistic regression. So the response variable is ordered categorical variable, so we cannot really use the linear regression model. And since this is categorical data, chi-square test is a natural choice. But the chi-square test only detects dependence, not tendency. But if you dichotomize the response variable and do logistic regression, then you can see what tendency each group has. And the result is basically the African American and Asian are more optimistic than white, maybe. I don't know. I think I'm kind of convinced by that, but that's
yeah, I
interesting.
think that's why in this data it's important to have other questions to assess anxiety and depression, because especially with Asian Americans, they tend to report more like somatic symptoms than like emotional symptoms, which can be missing in this kind of just single questionnaire.
Yeah. Does anyone have questions to Sakina? Okay, thank you. And I think that these are all presentations, and the comment submission form is available already. And I think that I'm uploading the 2 more presentations, the Jose's presentation and the Nadir's presentation by 12, and by maybe 2 a.m. today, tomorrow. And that's it. And thank you for participating in the class. And I have to take attendance in just a moment, please. And I think they are all presentations, at least in classes. The in-class presentations are good, so don't worry about the score for final presentation. And that's it for today and for the semester. Okay, so have happy holidays. See you.